Hey, what's going on, guys? Let's do this problem right here. So let's see how we can integrate this one using trigonometric substitution. So we have three cases right here. First one is when we have number square and a variable square. So in those kind of situations we use this one, x is equal to a sine theta. And when we have number square plus variable square, we use x is equal to a tan theta. And when we have a variable square minus number square, we use x is equal to a sec theta. So these are the three things we have to remember, right? So in this one, the one we have to integrate, we have a number. I can rewrite this one as x cube over square root of 4 square minus x square dx. So we have a number square and a variable square. So if you look at this, the first one is a number square minus variable square. So we can use this one right here. So in this case, x is equal to a sine theta. A is the number. So here we have 4 right here. I can use that one as my number. So 4 sine theta. And if I find the derivative, that's going to be dx is going to be equal to 4 cos theta d theta, right? This is the derivative of this one. And then what we have to do, we have to simply do the substitution. Instead of x cube, now I'm going to write 4 cube sine theta cube. So this is going to be 4 sine theta whole cube, right? And instead of this bottom right here, and instead of this dx, I can plug this one right here. So this is going to be 4 cos theta d theta. And in the bottom, we are going to have 4 square minus, so square root of 4 square minus this one, 4 sine theta square, 4 sine theta whole square, right? So let's begin this side right here. So here we have 4 is going to be cube, right? 4 times cube, 4 cube, and we have another 4 right here. So I can write this one as 4 cube plus this 4 power 1, that's going to be 4 power 4. So I bring this to the front, 4 power 4, and we are left with sine cube theta, and we have a cos theta d theta. So cos theta d theta. And in the bottom, we have 16, this one 4 square 16, minus this one is going to be 16 sine square theta. 16 sine square theta. So what I can do, I can take the 16 common in the denominator. So this is going to be 4 power 4 sine cube theta cos theta d theta divided by square root of, if I take the 16 common, this is going to be 1 minus sine square theta. So in this case, what I can do, I can plug this one right here, because I want to get rid of the square root. So what I can do, we know that cos square theta plus sine square theta is equal to 1, right? So I can write 1 minus sine square theta. So cos square theta is equal to 1 minus sine square theta. So this whole thing is equal to cos square theta. So this is going to be integral of 4 power 4 sine cube theta cos theta d theta, and I take this 16 already out, so that's going to be 4. In this square root, we are going to have cos square theta, because I am replacing this 1 minus sine square theta by cos square theta. And let's take this square root out. So that's going to be 4 power 4 sine cube theta cos theta d theta divided by 4 cos theta. So I can cancel this cos theta right here, and we are left with this one right here. Also I can cancel one of these 4, so this is going to be 4 cube right here, 4 cube sine cube theta d theta. Since this is a constant, I can bring to the front. let's use a different color. Okay, so I'm bringing this 4 cube to the front, and we are left with sine cube theta d theta. So in this case, whenever we have an odd power, we try to divide this one into two different things like square theta and sine theta. So let's do that. 4 cube sine square theta sine theta d theta. And we know that derivative of cos is sine, but we have sine right here. So what I can do, I can convert this one into cos, so I can do u substitution, because in order to do the u substitution, we have to have something. The derivative of something can be this one, right? Like in order to happen, that one to happen, I have to convert this one into cos. So what I can use the same formula right here. Instead of sine square theta, I can use 1 minus cos square theta. This equation I'm rearranging and using instead of sine square theta, I'm putting 1 minus cos square theta. So this is going to be 4 cube integral of 1 minus cos square theta and sine theta d theta, right? Now if I take the u as cos theta, I have taken care of this one. I have to do something over this. So if I take the derivative of this one, du is going to be minus sine theta d theta, but we have a positive sine theta d theta, so I have to bring the negative to the other side. So this is going to be minus du is equal to sine theta d theta. Then what I can do now, I can write the u equation like in terms of u. So this is going to be 4 cube integral of 1 minus u square. Here I'm going to plug this minus du, or I can bring the minus to the front and du here. So we have this one right here. Now this one is easy to integrate. This is going to be minus 4 cube, and 1 is going to be u, and this is going to be u cube over 3 plus constant, right? But I have to now substitute the u value, that's cos theta, minus 4 cube cos theta minus cos cube theta over 3 plus constant. However, if you look at this beginning right here, this is what we are trying to find. There's no theta right here. We plugged this theta instead of this x. We found this. We just substituted these values. So we have to convert this one back into x format. So to do that, what I have to do, I'm going to pick up this value right here and make a triangle. So if I make the triangle, so x is equal to 4 sine theta, therefore sine theta is going to be equal to x over 4. And if I make a triangle and put a theta right here, we know sine theta is equal to opposite over hypotenuse. So this is going to be opposite, x is going to be opposite, and 4 is hypotenuse. So we can find the adjacent, because we need the adjacent, because the last answer we have is in cos theta. So we need to find the adjacent. To find the adjacent, I can use the Pythagorean theorem. We have the hypotenuse, that's 4. So this is going to be square root of 4 square minus x square. So this is our adjacent. Now I can write this one in terms of x. So let's use the red color. So we have minus 4 cube, and instead of cos theta, I'm using adjacent over hypotenuse. That's going to be minus 16, because 4 square is 16. 16 minus x square over 4. And then cos cube theta. I can bring the 1 over 3 to this side, and in the bracket cos cube theta, right? So this is going to be cube of this whole value. So this is going to be 16 minus x square over 4 cube, and that is our cos theta and plus constant, and this is our final answer, right? And that's how it's done. I hope you guys like this video. See you next time.